Alright guys, now we're going to look at what pictures are and how they're stored in a computer system. Now, the two parts of a picture that are stored are the number of pixels and its color depth, which collectively, when multiplied, gives us the image size. Now we're going to look at the first element, which is the number of pixels. In order to understand that, we will define the pixel. A pixel is the smallest unit of a digital image that can be displayed or represented on a display device. This is the formal definition. It basically just means that as you see an image right here, each block that you see contains only one solid color, meaning each block has only one color or a shade, and that single block, that smallest block of an image, is called a pixel. Now, how do we calculate the number of pixels in an image? Is by counting the rows in that image and then counting the columns and multiplying that. It gives us the resolution or the number of pixels. Once you have the number of pixels, you multiply that with the color depth. We will look at color depth a bit later. So before that, I'll give you an example of how an image resolution can look like. We can have an image with let's say we have 4 columns and 4 rows, so the resolution of this image will be 4 by 4 and the total number of pixels will be 16. So this right here for this image will be 16. Now we will move on to color depth. What color depth is? Now each pixel has its RGB value, and the amount of bits that we reserve for each of these colors is known as the color depth. So for example, if we only reserve 1 bit for each color, it gives us the color depth of 2 raised to the power 1, which is 2. So that we basically have a 1-bit color depth, and which will only have 2 possible values, which means red can either be on or off, green can either be on or off, blue can either be on or off, which means the only possible number of colors we will have here will be 2 into 2 into 2, which are 8 possible colors. 8 possible colors. Now obviously, if you used 1 bit of color depth, you will see very like ugly looking pictures there will be absolutely no colors and it will look kind of very ugly. So we use kind of a stronger bit depth. We have 8-bit, 10-bit and 12-bit and their relative comparisons underneath. So in an 8-bit value, we have the numbers ranging from 0 to 255, which are a total of 256 different numbers. So each red, green and blue can have their own shade, and the number of shades, the possible shade values per channel is 256. Multiplying all that, we get about 16 billion possible colors if we use a bit depth of 8-bit. Now in the same way, we get 1 billion possible colors if we use 10-bit and about 68 billion possible colors if we use 12-bit per pixel. Obviously, with the bit depth, the size of your image will increase and your computer will need more space to store a single image. Now let's say you have an 8-bit image with a resolution of 1024 multiplied by 768, which is quite common among PCs. So you have an image size of 1024 x 768 x 8, which gives you 6291456 bits. Now you can convert it into megabytes or kilobytes, whatever you want, and this specific image will have the size of 768 kilobytes. Now if the bit depth was increased to 16, this will be twice as large and will become 1536 kilobytes, which is roughly equal to 1.5 MBs. What a computer does is it basically stores the data of each and every pixel of an image and some extra information about the resolution or the source or the date modified, etc. of an image, and it combines all of that into a single image file, which you can possibly remember as a JPEG or bitmap or whatever format you're using. Now I'll show you a little table of how many possible colors you can have with a varying bit depth. So you have 8-bit giving you 16.78 million colors, and when that 8-bit increases till 16-bit, the number of the possible colors that you can have is 281 trillion, which is a lot, and that image size will possibly in about tens or hundreds of MBs, and it will be quite vibrant, and you will be able to zoom in and look at very crispier details of the image. And thank you for watching. This is all you need to know about how pictures are stored. Thank you. Alright guys, now we will be looking at how sound is stored in a computer system. Now there are three elements that you need to consider before you know how to store a sound in a PC. So you have your frequency multiplied by your bit depth multiplied by your channels, and that gives you a bit rate of how many bits you need to store for a single second of your sound file. So starting with the first element, we have frequency, also known as the sample rate. Now what a sample rate is, its formal definition is the number of audio samples captured every second, meaning the number of samples of audio that are recorded by the microphone in every single second. Secondly, we have bit depth. The formal definition is the number of bits available for each clip. Each clip right here stands for a sample, meaning how many bits do you need to store a single sample. At the end, that equals to bit rate, we have the bit rate. The formal definition is that the number of bits used per second of audio. Yeah. Now we're going to look into the details of what a sample rate is. Now what a sample rate is, you have your typical sound wave like this, and what a sample rate is, it is the amount of values, like these green arrows that you see are the number of values that your computer will record digitally in order to most closely resemble the sound wave. It obviously will need. Now these are there are three things that are recorded in a sample. There's your amplitude, meaning how loud your voice is. Then you have the tone, meaning how the sound is coming out. Then you have the frequency, meaning the pitch of the sound. This is what a typical sample consists of, and these green arrows represent a single sample that has been recorded. Now in a typical CD, you have 44,100 samples taken every second. That's why the recorded digital wave is so smooth. But as an example, as a comparison, I'll tell you about the VoIP quality, video output in quality, which is, now I'll talk to you about VoIP quality. VoIPs are basically your online calling apps such as Facebook Messenger or something. They sometimes utilize the 8 kilohertz sample rate, that is 8,000 samples per second, because that can easily and quite accurately represent the human voice, but it breaks when you have to record songs or something which won't sound as accurate as the original ones. But because the sample rate is lower, the total size of the data transfer decreases. That is why the internet can be utilized to enable the communication. Now there are two equations that you see here. First is the size of an audio file, which comprises of bit rate multiplied by the seconds of audio in a file. The second equation is a typical sample consists of your amplitude, tone, and frequency. This is not really mathematical. You should not think of it as something that you will calculate. It is just the amount of things that a single sample comprises of. Now that we know what a sample is, we're going to look at bit depth, which means how many bits are we going to reserve for a single sample. Now the higher the bit depth means the higher number of values we can reserve for each of these three things. Meaning if we have a higher bit depth, we'll be able to store many different values of amplitude, many different values of tones, and many different possible values for the frequency. So a higher depth for a sound will ensure a more crispy voice with more detail. Now we have some mathematics here, and I'm sorry that you have to put up with this, but I guess you need to know how it works. So let's say there's a sample sound we have taken our typical sampling rate, which is 44.1 kilohertz, It is measured in hertz because it's 44,100 samples per second. Then you have a standard 16-bit depth, which means 16 bits are reserved for each of these 44,100 samples. And then we have this 2. Now this 2 right here is the channels. You see channels right here. Now what channels generally means, it means the sources of data that are existing. Like for example, if you place a microphone, there's a right side to it and there's a left side to it. So typically we consider 2 channels, meaning sound coming from the right and sound coming from the left. So we are multiplying it as a general case with 2, then we get 1411200 bits per second, and that is the number of bits that will be needed to store a single second of your sound. Then we have a typical 3-minute song. We multiply that with 60 to get the total number of seconds. Now multiplying the total number of seconds into the bit rate or bits taken per second, we get the total size of our audio file, and that audio file roughly makes up to 30 MBs of data, which is quite large and can require a lot of space. So in later videos we will be discussing compression of such files so that they can be transferred easily over the network or some other medium. Thank you very much for watching. Alright guys, in the previous 2 segments I explained to you how pictures and sounds are stored in a computer system. Now what a video basically is, let's first read the formal definition. A video just comprises a series of orthogonal digital images displayed in rapid succession at a constant rate measured in frames per second. Each image comprises a raster of pixels represented by bits. As said earlier, the more bits, the more subtle variation of color can be reproduced, called the color depth of the video, the most important property of a video used for its representation based on above are bit rate and video size. Digital films also have a bit rate that accounts for the total audio and image processed every second. So we can see that video is basically has the same storage methodology as an audio. We have this formula right here, frequency multiplied by the bit depth gives us the bit rate. So what a frequency is the number of images that a video will display per second. It is typically 24 FPS for movies because 24 frames per second is the speed of images displayed consecutively that our human mind will not notice the difference. Then we have the bit depth, which is collectively the total number of bits reserved for each image represented every second, plus the amount of samples and the bits reserved for the samples of audio taken every second. Multiplying both of these gives us the bit rate, meaning the total number of bits that our video will consume for every single second of it. That is basically all you need to know about videos, and I think that is all you need to know about how to store all the different data types in a computer system. In further videos we will be discussing different formats such as MP3, MP4 or other sorts of compression techniques to make our data storage and data representation better. Thank you very much for watching. Please press the like button.